So here we'll go through some polar plots. These are a lot more accurate than I could ever draw. So quite a variety here. You circle, spiral, some lines, and then some circles, and then the videos after this are on cardioids and rose curves. Let's just go in on how you would graph these. So this is probably the simplest one that you can plot. It's a circle, and it's centered around the origin. And this circle happens to have radius 2.5. So each of these gray circles has one length away. So I go from the origin to the first circle, I'm 1 away. Go to the origin to the second, I'm 2 units away. Origin to the third circle, I'm 3 units away. So the circle we have is 2.5 radius, so then we're halfway between 2 and 3. Right, and this is kind of like y equals 4, y of x equals 4. There's no theta explicitly on this side. So no matter what you plug in for theta, you're always going to get the same r value. And so you can go through and plot. So I actually have pi over 8s as I'm going around here, but I'm using pi over 4, pi over 2 increments here. So 0, pi over 4, pi over 2, 3 pi over 4, pi, so on. You get the same value each time. And another way you can do this if you don't want to go through and plot out all those is you can plot the graph. And you can say, okay, well, no matter what value of theta I have, I'm always going to get value r of theta is 2.5. So now on to the next one, which is an Archimedean spiral, so a little more interesting. Its formula is r of theta equals theta over 2 pi. And so in this case, I've graphed out 0 to 6 pi for the spiral. I ran out of room on my table, so I only went to 4 pi. But pretty much as you're going around, every 2 pi times you go around, right? So that's one rotation, theta from 0 to 2 pi. The radius increases by 1. So if the theta starts at 0, then you have 0 for r of theta. If theta is 2 pi, then you're going to have r of theta is 2 pi over 2 pi is 1. But if theta is 4 pi, so you've gone around twice now, then 4 pi over 2 pi is 2. And so every time you make one revolution, you're going to increase the radius of the spiral by 1. So here you can kind of see that. So in the middle here, we start at 0, and then you start going around, right? And you started at 0 radius, and now you're at 1. You go around again. Now you're at radius 2. You go around again. Now you're at radius 3 when you've done 3 revolutions. So this is called an Archimedean spiral because the distance between the spiral as it's spiraling outward from every point is 1. And right, we could also have used a graph of the functions. So if we have r of theta versus theta here, and we plot from 0 to 6 pi for theta, then we just have a line going from 0 to 3 when we get to 6 pi. And so that could have helped, instead of doing a bunch of number calculations, you could have plotted that out and said, okay, well, I increase linearly, and you can kind of figure out, fill in the gaps, what this shape is going to look like. The next one is a horizontal line. This has a kind of a weird formula. You wouldn't probably guess this, but if you do the conversion from a horizontal line, y equals 2 to polar coordinates, this is what you get. And this one you have to be careful. So we're only going from 0 to pi here. And so if we go from 0 to pi, graph cosecant, so that one, the graph might help us a bit. So if we go from 0 to pi, we're in this region. The radius is always positive, which ideally that's the case, but you can't do that for all polar graphs. But what happens here is when you're at actually 0 for theta, cosecant of 0 is undefined because essentially you're going out to infinity. And that's kind of like a line that you tried to just make infinitely far, and you wanted to try and intersect this horizontal line at y equals 2. But you couldn't because it's parallel. But then once you get to pi over anything above 0, your line isn't quite parallel anymore. If you go far enough, you'll have to go really far. But if you go far enough, you'll eventually intersect this line, you'll get a dot. But it takes a while to get there. So even the pi over 8, if I continued this line, we would have intersected somewhere around here. I didn't have enough room to plot that. All right, you have to do r is 5.2 when theta is 5.8 to get to this line. If you're at pi over 4, then you had to go, let's see, what is that, 2.82, so right, a difference of, 2.4-ish, right? But then going from pi over 4 to 3 pi over 8, so another pi over 8, that's only 0.7, so that's quite a decrease in how far you have to travel. And you get to pi over 2, so now you're at the bottom of this cosecant well, And now you're going straight up, so if this is at height y equals 2, then the radius better be 2 if you're going up to the line y equals 2. And then it's symmetric when you go past. So if we go to 5 pi over 8, we get 2.1647. Same thing at 3 pi over 8, right? It's symmetric, so that's the 5 pi over 8 value. Then travel at the 3 pi over 4 theta, you get the 2.8284 value. And then the 7 pi over 8, you have to go to another 5.2262, so somewhere over here. And then if you plug in pi, you get undefined because you essentially have to go, the line is parallel, so they never intersect. There's also a vertical asymptote here. So one thing to keep in mind in this one is you do have to make sure you have the right theta values, so 0 to pi. And you actually get a duplicate of the line if you go from pi to 2 pi. So if we take a look at that in the next slide here. So here, this one is actually from pi to 2 pi. And so same thing here, if pi isn't defined, 2 pi isn't defined, it's at the vertical asymptotes. But all the r values are negative now. So what do you do when r is negative? You essentially take the direction of theta that you're supposed to travel in, and you go backwards. And so if we're at, let's do 3 pi over 2 to start. So if the theta value is 3 pi over 2, that points in this direction, straight down, but the r value is negative. So normally, you travel straight down if r was positive, but r is negative when theta is 3 pi over 2, so you actually travel backwards. And so this is kind of r equals negative 2 in the 3 pi over 2 direction, so opposite. And you get the same numbers as before, but you're essentially going backwards. So when you're at 9 pi over 8, you travel negative 5.2262. So normally you go this way if r is positive, r is negative, so you travel over here. And this is theta is equal to 9 pi over 8, and r is negative 5.2262. And same if you're at 5 pi over 4, then you have negative 2.8284 as the r value, so you travel backwards, and you get to the dot on that line. 11 pi over 8, negative 2.1647, travel backwards, you get to this dot. 3 pi over 2, r is negative 2, travel backwards, you get to this dot. So you're actually retracing the line again. And so you do have to be careful. If you had done 0 to 2 pi, you would have traced the line going around once, you would have gone this way. And then when you got to pi, you would have actually gone backwards and done it again. So that was half and half. The first one you had both, all positive. The second one here, it's all negative. But the next one is going to be a little bit of both. So if you do a vertical line, and you start now, so we have, this is going to be to secant. So if you use the identities for translating from polar, Cartesian to polar, and you want to do x equals 2, you'll get this equation. And if we start at theta is equal to 0, then we actually start at value 2, because secant of 0 is 1. And so we travel from the origin along the theta equals 0 direction, 2 units, we get to this dot. And the next one, pi over 8, we're going to travel along this line, positive r, we have a positive r value, so we end up getting this way, we hit this line at this dot. Then 3 pi, pi over 4, 2.82. Then 3 pi over 8, it's a little bit off the grid here because it's getting pretty far away on the line, but somewhere up here. And then you have an undefined at pi over 2, which is this vertical asymptote. But then you keep going past pi over 2, you're at 5 pi over 8, and it says, okay, well, travel in this direction, but r is negative, so go backwards, so you're actually going to travel this way, and you get to a dot somewhere over here. If you're at 3 pi over 4, then you're at negative 2.8284 for r, so travel backwards, get to this dot. 7 pi over 8, travel backwards because r is negative, you get to this dot. And then when you finally get to pi, then that would be positive r, but negative r, you go backwards, you do it again. So you actually have, the way that you trace this out is theta is increasing from 0, you go up this line, and you keep doing that until you get to pi over 2, where it's undefined. And then you start way down here, and you start going back up, and theta equals 0 and theta equals pi are both at this point. So things get a little more tricky when you have r negative values, and especially when you have mixed positive and negative values for r at different thetas. Now for the next one, which is going to be a little more interesting. This is a circle that's been offset. So it's here, I only have one gray circle here, so this is at radius 1. And then this is a circle, it's radius 1/2, and its center is at x equals 1/2, y equals 0, right about there. So this one we're doing just r of theta equals cosine of theta, which I didn't imagine it would make a circle the first time I went. And we also have to be careful here that we're doing 0 to pi. The reason for that is if we start at theta equals 0, then we're at the r equals 1, so go in this direction, travel 1 unit, we get to this dot. We go to theta equals pi over 8, we're at 0.92, it's not a whole lot of decrease from 1, but we travel pi over 8, we get to this dot. Then we get to pi over 4, 0.7, we get to this dot. 3 pi over 8, we had a pretty big increase there, so it went from like a 0.08 decrease to a 0.22 decrease to a, what is that, 3.32, I think. So starting decreasing faster, so this dot, this dot, this dot. Finally you get to pi over 2 right there, and you're pointing vertically, but the radius is 0, so you just end up at this dot. And now you keep going, and you're at 5 pi over 8. Well, okay, you're supposed to travel in this direction, but now cosine is popping out a negative number, and so you're actually going to travel over here. Sorry, over here. And then at 3 pi over 4, that would be positive r direction, but r is negative. You get negative 0.7, so you travel here. At 7 pi over 8, you're going to have negative 0.92 for r, so you travel this way. And then finally you come back around to pi, and it's the same point as theta equals 0. So you actually you complete one revolution of this offset circle from 0 to pi. You don't have to go from 0 to 2 pi. If you go from 0 to 2 pi, you trace it out twice, actually. So the order of the points here, we start here, theta increases, then r becomes negative, and theta increases. We get back and we complete our circle. So this was a little annoying to do because we have mixed r positive negative values. So if you actually picked the range of pi a little bit differently, you could have stuck with all positive. So for instance, if we did, instead of 0 to pi, we did negative pi over 2 to pi over 2. So we're going from this theta value, rotating this way up to this theta value. Then we actually have all positive r's, because now we're still in r theta equals cosine, and we're going from negative pi over 2 to pi over 2. Cosine's positive the entire time. So if we do that, we start at theta equals negative pi over 2, which cosine of negative pi over 2 is 0, so pointing down, but we don't travel any distance. Then negative 3 pi over 8, we travel to 0.38. Then at negative pi over 4, we travel to 0.7. Then at negative pi over 8, we travel to 0.92. And then when theta is equal to 0, we travel to 1, and then kind of the same thing on the other side. So in this case, you're actually starting this way and you're going around, and then when you're done, you actually end back at this dot. So if you can, you usually want to try and keep r positive, but again, that's not always possible. So this one was negative pi over 2 to pi over 2 for this offset circle, but if we draw a slightly different offset circle up here instead, then we can actually use the normal 0 to pi, and this is going to be r theta equals sine of theta, if you want to do this offset circle. And in that one, it's nice to pick 0 to pi because sine of theta is always positive between 0 and pi. And again, you only need 0 to pi, not 0 to 2 pi, otherwise you'll go through twice. 0 to pi, you'll only go through the circle once. And really quick, theta is 0, r is 0, then theta increases to pi over 8, you get this dot, pi over 4, this dot, this dot. When theta is pi over 2, that's when sine has its greatest value, so you go up to there, and then you come back around, you start decreasing, and eventually you get back to pi, and when theta is pi, sine of pi is 0, so you complete the circle here.